So this first example, I'm going to show you a case where we have a permutation, a combination, and neither. And what's important is to make sure you understand the difference, because that's sometimes the hardest part. Which case is a permutation, which case is a combination, and which case is neither of those. Alright, so suppose that I have a high school basketball team, and they have an awards banquet at the end of the year. There are 12 players on the basketball team, so that means N is 12. Right? We have 12 total players. Suppose 3 awards are given: Most Valuable Player, Most Improved Player, and Sportsmanship Award. Alright, so the first question is, how many? So again, we're asking for the count. Different ways can the awards be given if a player cannot receive more than one award. And so that last part means no repeats, right? Once somebody's been selected for the Most Valuable Player, they cannot be picked again for the Sportsmanship Award. Alright, so that narrows it down to it's either a permutation or combination. So now I need to decide, is order important? Suppose the first award given is the most valuable, the second award given is the most improved, and the third award given is the Sportsmanship Award. Does it matter which one of those you're selected for? Is there a rank to them? Yeah, there is. Some people might prefer to get the most improved over the sportsmanship. Alright, or the most valuable player over the most improved. So again, there is a rank to it. You could rank which one you would prefer. And so order matters. Because there's a rank. There's a first, we'll say the first is most valuable player, there's a second most improved player, and there's the third Sportsmanship Award. Right? It matters. If you're picked for most valuable, that's it. You're done with that one. And so, again, it's different than if you were picked for the Sportsmanship Award. And so, order matters. And so, that means this is a permutation, where total players, and we're picking 3 of them. So, we start with 12, and we're gonna pick 3 of them. And so, we want to know, well, how many different ways could I take 3 from 12? So, it's a permutation, 12. Permutation, choose 3. And so again, I'm going to go ahead and type that out on the calculator. And so there are 1,320 ways to hand out the award. All right, that's how many different ways to hand out these 3 awards. Alright, so that was so in process of elimination, we've done the permutations case. But make sure you understand why this is a permutations case. Alright, part B, how many, so again we're counting, can the awards be given if player can receive more than, so then, and technically speaking, somebody could win all 3. Alright, suppose you had an outstanding player, he was the most improved, and he was the most valuable, and he had the best sportsmanship. And so in this case, we're allowed repeats. So it's the neither case. You cannot use permutations. You cannot use combinations. So you have to use your and or statements. And so we're going to pick somebody for the most improved. We'll do most valuable since I did that. Most valuable and most improved and the Sportsmanship Award. Alright, so we're using ands, which means we multiply. We had 12 players to choose from since we could repeat players. For each one of those, there were 12 people to select one. I could pick 12 people for the most valuable. There are 12 picks for the most valuable. Since I'm allowed repeats, there are still 12 for the most improved and 12 for the sportsmanship. So it's 12 times 12 times 12, which is 12 cubed, which comes out to be, there's more options because you get repeats. Alright, so if I'm allowing players to have multiple awards, I now have 1,700, and it should make sense that it's bigger, because you have a group of all of the same. All 12 players could win all 3, right? That's a group. So 1,728. Alright, so by process of elimination, that means my part C was the combinations case. But again, make sure you understand why it's the combinations case. So we're going to go through the why it's the combinations. So we're still picking 3 players. Suppose that 3 players are going to be selected to attend a camp. How many different ways can the selection be made? So we're not handing out awards this time. We're just going to pick 3. So R is still 3. We still had 12 to start out with. So 12 is still my total. But this time we're picking a group to go to camp. Does it matter what order you're selecting? If you're picked first to go to camp or last to go to camp, does it matter? No, you're all going to camp, whether you're the first selection or the second or the third. And so order is not important. You just want the different groups. They're just groups with no order. And so this is the combinations. Right? Which again, the combinations, how many groups of 3 can I select out of 12? So I start with 12 as my n, combination, choose 3. And so we'll use the key on the calculator, 220. Right? And again, it's a lot less because we're eliminating reorder. Right? Permutation was 1,320. The neither case was the biggest case, right? Because we're allowed repeats. That's 1,728. And the not ordering people and a not allowing repeats, again, it's understood that there's no repeats, I guess I should say that. Because you have to pick 3 different people, right? If I pick the same person twice, they're not different. You only pick 2 people. Right? No repeats because I need 3 people to go. So again, the combinations is the smallest group, and it's always the smallest group because you don't have repeats, and you don't have reordering. Alright, so you only have 220 different ways to select 3 groups where order is not important when you're selecting from 12. Alright, so that was an example to try to get you to understand the difference between how is a permutation different than a combination, and how are permutations combinations different than the neither case. Right? And again, the biggest thing for the neither case is we're allowing repeats. Alright, so that was that example. I'm going to stop there. In the next one, we're going to just look at permutations and then combinations individually.